it's only a pleasure to me to introduce Pierre de Jager. Pierre obtained a BSc honors from the Nelson Mandela University in Quebec and has pursued a career which includes diamond exploration with De Beers Consolidated Mines, geophysics with KCI, mine geologist at Kloof Gold Mines, and GFSA, group geologist for multi-gold holdings, and exploration geologist with Rand Mines. He has been self-employed since 1989. He owned and operated Alluvial diamond mining project in the Northern Cape and has subsequently become a highly knowledgeable consultant alluvial diamond geologist with over 20 years experience in the Middle Orange River, Northwest Province, the Diamond Triangle of the Northwest Province, the DRC, Angola, Sierra Leone, and Cameroon, and other areas of Southern Africa. I had the privilege to drive with Pierre about 30 years ago from Douglas to Windhoek, and it was such a pleasure to have the knowledge next to me, because our trip felt like 2 hours to me. But Pierre, over to you.
Thanks for the opportunity to present this article. If you look at this map here, it's contains most of the alluvial deposits in South Africa. And the purple triangle is the area that I'm going to be talking about. Zwaziland, Bloemhof, and Wolmaranstad. It's the southern Northwest Province, also known as the Diamond Triangle. Diamonds were discovered in this area in 1912. Small-time diamond miners have produced more than 5 million carats since 1912. It's a well-sorted, rounded population. Average size about 1 carat per stone. Exceptional good quality, and it's famous for colored stones such as orange and blues. Average price is $800 to $1,200 per carat. And then the famous geologist De Tooy in 1910 already recognized the dry arch as a glacial valley, and he also realized the island between the Harts and the Vaal rivers is the Pre-Dwighter topography, nowadays known as the Cargonian Island. And then one of the very interesting people that was involved in this area is exploration diamond geologist of Anglo-American von Godberg in 1970, and then he noticed widespread deposition and occurrence of Dwighter sediments in the area. Here's just a couple of photographs of some of the parcels you get there. 85% gemstone. This is 4 diamonds from the late Mr. Dick Barker. Here's some of the colored stones, the famous one. There's a blue 3 carat, 7.5 vivid orange, 26 D-type. This is just a geological picture of the area, of the old geological map. The red contour line represents the Cargonian Island as we know it today. And the important is this Archean granite with Amalia greenstone belt in this portion. We've got quite a lot of Ventersdorp lava, Ventersdorp sediments in this area towards Houtvolop. And then you get quite a lot of Ecca sediments on the Cargonian Island. And I'm saying this already, we're looking at this area as a glacial outwash plain. A summary of the geology of alluvial deposits. Archean granites and greenstones of Amalia belt and Proterozoic Ventersdorp supergroup lavas and sediments form the Pre-Dwighter topography. These Archean and Proterozoic rocks represent the southeastern margin of the Cargonian Island, as you see here. And the area is flanked to the northwest by the Harts River, if you look at as a glacial valley, and towards the south by a glacial outwash plain that contains glacial streams that is represented by so-called diamond runs, like the London Run, the Zevenfontein Run, Oelsonskraal, the Bamboes Run, the Zoutpan Run, the Quasi-Spruit. And in between these glacial outflow streams, you get the plains with a lot of glacial debris on, and the glacial debris, we're looking at Lotsmantel, reworked moraine, and kettle structure. And then close to the Cargonian Island, we got the Permian Ecca sediments overlying the Dwika. And in this middle Ecca beach deposit, on and against the flanks of the Cargonian Island, occur almost entirely as a secondary regular feature between the 1350 MASL contour, which is this one, and the 1400 MASL contour. And this regular gravel covers almost the entire Cargonian Island from Schweizerreneke to Wolmerhofstad and beyond. Now, first of all, I'm going to look at the Dwika, and then I'm going to talk about the Ecca. So generally, the Karoo and the Kalahari basins will remain depositional areas of the Dwika sedimentation, and the Cargonian Islands separate these two basins. This purple triangle is the area I'm going to talk about. It's partially lying on the Cargonian Island and partially lying in the Main Karoo Basin. The Zimbabwe Craton and the Kaapvaal Craton were the main source areas for the sediment in these areas. Just note the amount of pre-Dwika kimberlites on the Kaapvaal and Zimbabwean Cratons. Things as a Premier, Venetia, Marnets, Titebridge, Martinsdrift, in the Mengenesi. And we look at this table over here, the pre-Dwika kimberlites, and I'm going to be talking about the Ecca and the Dwika group, and there's all the post-Dwika kimberlite. This is a digital elevation model of a southern northwest province with a vertical exaggeration equal to 30 times. And this gives you quite a good idea of the Cargonian Island in this area here. The blue dots represent production of 0 to 10,000 carats for each of these dots. And you can see it covers quite a bit of this Cargonian Island. And even up all the way towards Ottosdal, you every now and again find some production. And this represents the glacial outwash plain. So you see the higher dots, the green and the yellow, and sometimes the red, is situated in the glacial streams and very rarely on the plains between the glacial streams. This is the Hars River coming down here, and this is the Vaal River coming down here. I just want to say that in 1910 already noticed this highland between the Harts and the Vaal River as being older than the surrounding Karoo rocks. And van Godberg again in 1970 noticed the widespread deposition of this Dwika sediments over the entire South Northwest province. And an area of typical landscape features such as Rousset Moutonnies and glacial striations. This diagram represents a terrestrial glacier deposition model with typical glacial streams, ground moraines, outwash plains, recessional moraines, and end moraines. And if we superimpose that model onto the area we're talking about today, we interpret it as all these so-called diamond runs, the Quasi-Spruit, the Bamboes Run, the Zevenfontein Run, the London Run, all as glacial streams with the glacial debris deposits in between. In this diagram, we superimpose a terrestrial model. Yeah, that's the one we just had a discussion. The so-called diamond runs represent reworked glacial streams, and the areas between the glacial rivers represent the lodgement and reworked moraine deposits. If we look at the glacial rivers, they normally represent a braided river system with a poorly sorted gravels and mud layers with large braided sandbars. Now, these glacial rivers are between 40 and 60 kilometers long, but they're 400, up to 400 meters wide, with 8 meters thick, and they don't have any fall width. If you look at a modern day Oros River, where the average width is approximately 400 to 500 meters wide, similar to these very short rivers, then it's hard to justify a fluvial braided system over this short distance and the width of these gravels, except if you look at a glacial river on a glacial outwash plain. Now, these glacial river gravels consist of matrix supported small pebble to small cobble gravel with angular to sub-rounded to well-rounded class in a sandy matrix. Now, first of all, I'm going to talk about the farm Oersonskraal. That's on a bamboo spruit. We're going to look at some of those gravels. Then we're going to look at a farm London on a London run. And lastly, on a farm Ganspan on a Zevenfontein run. So this is on the Oersonskraal, bamboo spruit. You see in the sump, there's your Dwaika Glacial River gravels. And just on top of that is a reworked Dwaika Glacial gravel. And normally the big companies would mine right up to the Dwaika Glacial river gravel. And unfortunately, there's a close-up not so good, but there's the glacial mud deposits, and then you find quite a bit of pebbles in between the mud, and then a reworked glacial gravel. We go to a London deposit, reworked glacial gravel, large Ventersdorp boulder, Dwaika bedrock again, after they mined the top reworked gravel. Glacial River Zevenfontein run on the farm Ganspan. Very typical, the 4 meter calcrete layer on top, then reworked Dwaika, and then into a Dwaika. Here you can see the glacial Dwaika containing all the pebbles, and it's a small cobble with angular to sub-rounded to well-rounded class in a very sandy matrix. Very typical of the Dwaika. We all know the class shapes range from angular to well-rounded, poorly sorted. The gravel class consists of Ventersdorp lava, Ventersdorp quartzite, Transvaal brown quartzites, agate, jasper, buff, and church class. And the gravel normally has what we've seen, the 3 meter hard concrete layer. Simon Baer, 1964, described similar gravel, similar stratified Dwaika deposits close to the Ecca in the Bothaville heavy mineral deposit. And you can see the cobble class, and in between there's some very rounded pebbles. And it's a wide range of shapes. So the areas in between the glacial rivers represent glacial plains with Lotsman till, ablation till, reworked moraine deposits. And these large angular blocks of Ventersdorp lava lies in a coarse sand, and occasional sub-rounded cobbles, and very rarely any pebbles, which is very odd. Again, if you look at alluvial diamond deposit, the only way to explain this is in a glacial environment. And you can see here as well the angular class in a sand matrix. This is on the farm Graspan between the London run and the Zevenfontein run. And we interpret at the moment all the pans as kettle structures. Just a slight definition of what a kettle structure is. There is numerous pans on this glacial outwash plain. If we go to the Ecca, lying on and against the flanks of a Cargonian island. Here I just got a contours of a 1360. Actually starts in a 1350. And again the blue dots, sorry. And again a vertical exaggeration 50 times. Go on to a Cargonian island. try to emphasize the Ecca on this, the Ecca deposits on this Kergonian island. For now, we're going to look at it first of all on the farm Doornhoek. Then we're going to go look at Pondfontein, Mimosa, and then Oudvolop, which is next to Oudvolop. The areas with the Ecca sediments occur as a regular gravel over almost the entire Kergonian island as a ferruginous small to large pebble gravel with pisolitic laterites and saprolites. And on the farm Doornhoek, the secondary gravel grades from a 0.5 meter thick lateritic gravel into 8 meter thick primary quartz reed sand with thin gravel parting. So this is actually the primary middle Ecca marine deposit. It's a quartz reed pebbly sand and a pebbly gravel and a quartz reed sandy matrix. A little close up, and you can see matrix supported gravel. There is a gravel parting again in the sand. And if one just look to emphasize the sand, the quartz reed sands, the typical marine deposit, these quartz sands again here as well. Now this is not, you don't see this very often, this primary middle Ecca deposit. Predominantly you'll see the regolith gravels, which represent mostly reworked or chemically reworked primary Ecca deposit. So this regolith gravel consists of 0.5 meter to 1.5 meter thick large pebble gravel to a small cobble gravel, covered by red sand up to 3 meters thick. The gravel class consists of Ventersdorp lava, quartzite, agate, jasper, buff, chert, and very similar to the Dwyka Braidwood stream class, and probably reworked perlite in the marine environment. These regolith gravel occur on a lava bedrock, you can see here, and it seems to follow the bedrock contours and seem to be draped over this lava contour. Wherever it goes onto the quartzites, the Ventersdorp quartzites, it occurs as a marine stone line, which is, it looks exactly or very similar to the Western Cape shorelines, where you've got the Table Mountain sandstones or quartzites, and it's also sort of these angular blocks in between the marine gravels. If you look at the famous water table mini fields in the area, this is my farm Zitland. It's on top of a Kergonian island. These fields are very valuable. And it's actually extensive regolith gravels which form aquifers and ideal maize field growing conditions. And it's the chemically weathered Ecca marine gravel. This Ecca sediments occur, it corresponds very well to the Bothaville heavy mineral B sands of the middle Ecca. This has been described by Simon Baer 1965 and Hobday 1978. And it contains appreciable concentrations of heavy minerals such as ilmenite, garnet, chromite, phenol, zircon, rutile. And we know that garnets, ilmenites, and chromites are fairly common in the heavy minerals obtained from the diggings on the regolith gravels. Hobday described this middle Ecca as a quartzose sandstone with beach and nearshore characteristics. If you look at the farm Doornhoek primary deposit again, scattered pebbles in a medium to coarse sandstone represent the upper shore face deposit. That's the description of Hobday. So to my mind, this is exactly the same. The Ecca beach deposit originated in a non-tidal to a microtidal storm-dominated coast. If we look at the diamonds in the area, it occurs as follows. It occurs in the Carboniferous glacial outwash plains, on the reworked glacial rivers, and a reworked glacial debris. It also secondly occurs in the Permian middle Ecca beach deposits on the Kergonian Islands, in the primary middle Ecca beach gravel, and on the regolith gravel, which represent the chemically weathered middle Ecca beach gravel. Here's some production figures on some of the farms. And the first 4 London, Oesanskraal, Kameelkou, Gaanspine. Is from a reworked glacial streams. Stone, very similar except for Oesanskraal, which is the one furthest away from the Permian Island. The grades range from 0.49, the lowest grade on the glacial debris, and then the highest grade is nearly 1 carat per 100 ton. It seems that the average stone size for the glacial debris deposits are slightly higher than the rest. And then unfortunately, we only got figures for one farm on a regular gravel, the Ecca Marine shoreline. And that's got a carat average size of 0.76 and a grade of 0.67. Here's some of the problems that they have, and this is diamond lockup. This is after screening. Some of the Dwika blocks. Here you can see it's a Dwika gravel, very hard, and maybe in the future we'll come to some kind of crashing, especially with, now you know exactly what the average stone size is. But we want to discuss, though, here again, I just want to go through the evidence of diamonds in the Carboniferous glacial sediments and the Permian Ecca marine sediments suggest diamonds were transported from the interior to the southwest by pre-Karoo fluvial systems and Dwika glaciers. The 2A54 note a correlation between alluvial diamonds in the Carboniferous glacial sediments in western Brazil and Bolivia. Tompkins Gonzaga, 1989-1994, described diamonds from glacial outcrops in Brazil. Von Gottberg, 1970-2006, are convinced that the deposition of the Dwika rocks in the southwestern part of the Northwest province of a source of alluvial diamonds in the area. More and more 2006 suggests that it's from Abula diamond-bearing basal gravels, upper Karoo fluvial sediments, and associated heavy mineral suite represent the winnowed and concentrated lag products of a former Permian till with a distal provenance. So it was during the Carboniferous period when Gondwanaland drifted over the South Pole, Dwika glaciers played an important role in liberating, transporting, and deposition of the diamonds from the pre-Karoo kimberlites to the north and the northeast of the study area. For example, again, the Premier, the Marnus, the Venetia, Bright Pipe Bridge, and Martin Drift kimberlite. Glaciers move in a southwesterly direction, and just from this geological map. And then locally between Schweizer-Reinecke and Wolmerastad, this glacier was probably deflected in a southerly direction due to this granitic inlier in this way. Reworking of the glacial sediments during Ecca regression and minor transgressions phases produce considerable amount of heavy minerals, such as diamonds, garnets, ilmenite, spinel, and so forth. That was deposited in a beach environment with no or very small intertidal zones, bare and hot day. And the famous Bothaville, Delmas, Carolina, Ecca heavy mineral deposits coincide with the Middle Ecca. The Cargonian Island remnant represent the African surface as described by Partridge and Moore, 1987. But the Karoo sediments were subjected to a long period of chemical surface weathering that since the Cretaceous, and that forms a regolith gravel. And so thus the primary Ecca deposits are hidden in the regolith remnant on the Proterozoic and Archean rocks of the Cargonian Island. Then just a little bit of conclusions. The Northwest Province deposits are unrelated to adjacent Vaal and other land-based alluvial deposits. The diamond population is predominantly gem quality, well sorted and consistent in average size. Similar to other reworked shallow marine diamonds, is, for example, West Coast Marine, Namibia, even the Marangi, initially deposited by Carboniferous Dwika glaciers, with concentrations along glacial outward streams. and then reworked and redistributed in the Permian shallow marine shoreline setting, and then reworked by modern weathering. And just out of interest, I've seen similar looking Cretaceous gravels all over Africa, DRC, Sierra Leone, Angola, and just a couple of question marks. Acknowledgements, thanks, that's about it. I'd just like to thank the Farming and Alluvial Fraternity of the Northwest Province for all their help and things during the past many years. And then a special thanks to geologist John Ward for positive conversations and support in establishing the Middle Ecca shoreline, as well as the excellent photographs. And then also geologists John Bristow and Mike DeWitt for sharing their views and experiences.
Thank you, Pierre. You well ahead of time, so I think there's more opportunity to ask questions. If I'm from my side, something that I was privileged to attend was a presentation by Dr. Assie van der Westhuizen, where he said the following. He said the Orange River was identified as a likely conduit for the transportation of diamonds from the hinterland of the southern Africa to the Atlantic. However, the presence of marine and coastal diamond deposits as far south as Olifantsrivier estuary showed that the Vaal Orange drainage in its current form could not comprise could not account for all the diamonds transported to the coast, and researchers proposed the so-called two-river hypothesis, comprising of a former Kalahari River in the north, and which is more or less the area that you're talking about now, Pierre. To me, it looks like, looking at the map, more or less almost in the range where the current Molopo River is. And then he's also talking about the Karoo River in the south, but noting that it's a hypothesis. So all I'm asking is that he says more recent research results showed support for the former Kalahari River, but not the Karoo River. Have you got any comments on that?
Yeah, I think this is a little bit different. I think I'm looking at something a little bit older, probably, and I'm looking more at glaciers. And this, yeah, I think a lot of guys will nowadays know that the glaciers played a very important role. But to say that even the pre-Karoo fluvial systems as well, which were probably pre-Dwika. Yeah, so it's very similar, I would say. It's the Dwika is just a different ice deposits. Why the pre-Karoo rivers were sort of pre-Karoo, pre-glaciers.
Pierre, just page back to your summary diagram in your presentation, which is still up, and we can talk to it, and you make a valuable point. Yeah, that one, you've gone past it. No, you've gone past it.
Okay. Yes.
Now I mean, that's the critical one, and that's exactly what we're saying, Gert, is the whether it's the Kalahari, which effectively would have gone from Botswana, which also produces lots of diamonds in the hinterland, and we know again in Botswana, that they're old kimberlites. They're kimberlites the same age as Premier at Martin's Drift. So there were Dwika, there were glaciers back in the Carboniferous, effectively scraping off the landscape and transporting diamonds to the southwest in before the breakup, and we had the same thing, down into the Karoo Basin. So I think Assie's discussion on the rivers then came along, much big rivers, the Vaal and the Orange and the and the fish and their proto rivers all came along later. And so very simply put, I think the glaciers were critical for massive rock disaggregation or breaking up rock and transporting rock and diamonds. And then, in this case, in the Northwest Province Diamond Triangle, we had a concentration process go on in the Ecca. But, we then also had concentration in the younger big rivers. And then, of course, in the marine setting. So there's really, multiple processes going on here. And I think Lyndon in his talk shortly will also show, the role that the Dwika or the Carboniferous glaciers and rock disaggregation and rock and diamond movement will play.
Yeah, John, just a comment on the diamond populations. To me, it's always been a bit of a enigma in that, we transported the stones straight from Lesotho down to the Middle Orange River, and we still find these big, what Keith Whitelock used to call the fragile whites. We still find them there. And then suddenly they disappear, and the next 500 kilometers later, the sea, they're not there anymore. I mean, we've got a significant population of large stones in the Middle Orange River. And the population in the sea is a lot more like the population that Pierre described. And we know there's been a lot of shedding from the kimberlites, obviously, to the sea. But I think there was quite a big contribution from the glacial transport and the diamonds that Pierre is talking about down to the coast.
Yeah, absolutely, Lyndon. And I mean, the companies don't normally talk about it, but there are records of some, very few, but some big diamonds, 240 carats on the west coast as well.
Yeah, but too few in compared to what we are finding.
Yeah, no, I agree with you.
They seem to be somewhere. There's a couple of them missing out.
Yeah. No, I think, in my bias, the whole model fits together, rather well. I mean, and the one thing, if you go and drive around Scotland and other glacial areas, we forget the role that glaciers play just in fragmenting and breaking up and moving massive volumes of rock.
Yeah.
That's why you guys, Lyndon, use, top of the range 120-ton bulldozers to actually break up your gravel. It's the same principle on a much smaller scale.
Sure.
Okay. Other questions? We've still got a bit of time. Sorry, Gert, I've jumped in there.
Thank you. I appreciate.
And Amo had a question in the chat box.
I actually I posted my 2 questions on the chat, but it's fine. I can just
Okay.
So yeah.
Okay. The geophysics is always, I'm a bit probably outdated when it comes to geophysics, the recent geophysics, but we always found that electromagnetics is is the easiest to find river channels, especially where you get a Dwika bedrock. Because the top of a Dwika bedrock is normally slightly moist, which is a good conductor for electricity, and that just gives you quite a good reading. Even on the Vaal River as well, we found that it's probably better than S-band seismic. But again, I don't know what's the new things, resistivity and all that. I mean, geophysics is a field that's growing, but I know when I was young, electromagnetics seemed to work the best because of that, but you have to have a Dwika football.
Yeah, and Emma, one of the important pieces of outcomes from this work of Pierre and others has been the fact that they have identified, extensive shallow diamond deposits in what previously we called the interflue. So if you looked at those runs, and Pierre can explain it better than me. Typically in the past, everyone concentrated on the Bushman Spruit and the London Run and those, basic river systems. you know, what the work of Pierre and a lot of these, you know, small miners has shown is that there's a considerable resource of diamonds either up on the Cargonian highlands and those weathered Ecca sediments, and sort of on the
Cargonian highlands.
Ja, the
Ons in die
Cargonian-
middel van Suid-Afrika die Cargonian Highland gehad wat die
Okay, and then there's also there are also extensive deposits now that can be mined, you know, out on the outwash flats between those runs. Pierre, you might want to comment. And you know, many of the when you go there these days, it's quite hard to find many of these small operators because they're sort of away from the traditional areas.
Look, I just first want to look at the second question here. We're considering development of the brownfields or repurposing of tailing dumps in areas like Lichtenburg, Ventersdorp.
Thank you, Danny.
You've got to think all of these areas is slightly different. The average value of a stone. So Lichtenburg, Delarival is not so valuable as the Bloemhof area. Baker was not as valuable. Ventersdorp and Klaasdorp is more valuable. But the southern northwest, you've got a higher average value than in the Lichtenburg, Bakerville area. You've got to be very careful when you want to do tailing dumps in this area.
But you can also reprocess them with new technology, and then you're probably going to find some more diamonds that previous people would have missed. And I think Pierre's other important point is the lockup. But I don't know if these deposits would be economical enough to actually go and use big bulldozers to rip and truck like you do in the Middle Orange River, London.
We'll take a look at Bill McCartney's questions. Are you recovering diamonds from a Dwika? Yes, there's definitely been diamonds recovered from a Dwika. Unfortunately, if you talk about if you look at cumulative minerals, the modern day plants, you're not really, you cannot really see the cumulative minerals, the garnets and things. In the old days, with the old pans and things, it was possible. And but if you look at kimberlites itself, we've never seen any kimberlites in the Northwest Mountains. Nothing. That is, I don't know. We've worked there for a long time, and I think one of the interesting guys told to me is von Gottberg, and he could never find a kimberlite. And the Dwika, yes, definitely. The Dwika, you find diamonds in the Dwika for sure.
Well, thank you, sir. Well, I think, I mean, I must confess, I'm a non-technical individual, and unlike the more informed students in attendance, I'm basically looking at it from a layman's perspective. But that's the thing that makes mining such a special business, I suppose. It requires a collaboration of individuals from different backgrounds with different agendas and interests. But I guess the lesson is we have to wait for the technology to catch up, and then maybe the low grades will be a viable business in the future.
Just a comment about Kim's in the Dwika. There was a paper, I can't remember the exact year, I think it was the 1970s, by Marie, who was one of the very early people pushing the Dwika as a source of diamonds. And he was very strongly criticized. And in his response to the criticism, he actually reported having treated Dwika and getting prolific diamonds, garnets out of it. So that's the paper's in Afrikaans, so a lot of people probably found it inaccessible, and it would be really great to perhaps persuade the Geological Society to republish it with a translation.
I see there's a hand from Andy.
Yeah, sorry, that was me speaking ahead of my hand. I beg your pardon.
Do you know the locality, Andy?
it's a long time since I've read the papers, John, and I don't think he mentioned that, but he was obviously a little bit stung by the criticism, and he just mentioned that he, recovered pyrope garnets. But it was a very thoughtful paper, really worth getting that translated for people who don't speak Afrikaans.
Yeah, good idea. We've also got to go to some of these localities and take some big bulk samples, in a modern scientific method, and see what comes out of them.
Okay, here's a question from Jean Simonis about aquifers. You find them basically all over the Cargonian Island, in that area, and they're very valuable, and the farmers know it. They're very pricey with this land, and you're not going to get to mine in these aquifers very easily.
But interestingly, Pierre and Lyndon, you might want to add. I mean, we did some work years ago for an Aussie company called Moonstone, just south of Zoutpan, where Mike Rukin-Smith made his fortune. And we always found that those farmers, when there was a drought, they took that red sand or weathered, material off the top, and they mined the underlying gravel. And then when they had a wet year, and then they rehabbed, they put it all back very nicely. And in the wet years, they grew meaty. So they got a double bonus, or a double profit out of those deposits.
I see another hand there, Hendrik.
Yes, in the 70s, when I was a field assistant for De Beers, we did bulk sampling of the tillites north of Nieuwoudtville and found diamonds in.
Fantastic, Henny. So you're going to give us a presentation. Have you still got the samples and pictures?
Yeah.
I'm being serious.
Oh, I mean, it's back in the 70s. We're going to have to ask De Beers for their data.
Purely from someone interested in prospecting still, do you guys, with all the knowledge around the table here, foresee that there are any areas that's been untouched? I'm talking, the Mulepua, the Rimfas mark, those areas. Do you think there's still a possibility?
Are you talking alluvials, Gert, or kimberlites? You presumably mean alluvials.
Obviously alluvials.
Well, Lyndon and other experts?
Yeah, Gert, I think they are. I think as soon as you move north, you go into the Kalahari, and a lot of things gets covered by the sand. I think there's definitely in Botswana probably areas that would be worthwhile looking at if you can see through the sand, and the sand is a problem. And I think as geophysical techniques improve, we're probably going to start finding things. I remember when I was with the Beers, there were some drill holes in the Kalahari that intersected old riverbeds, and I can't remember exactly where it was, but there were some indicators coming out of that as well. So I think not only alluvials, but also kimberlites, I think there's still a couple of things to be found. And whenever we can look through the Karoo cover and see what's underneath, there might still be a few surprises. But I think it's going to be technology dependent on finding them. I think the easy ones have been found.